Meerkat here, and welcome to episode 3 of our beginner series for Pong. Last episode we got a ball moving, but there is a couple of issues with detection on the paddles, so we're going to fix that today. We're going to do a bit of debugging, and we're also going to make it so you can slightly change the direction of the ball. We're also going to have goals as well, so if a ball connects with a goal, then it's going to destroy the actor and spawn a new ball in the middle of the game, effectively making it an infinite game. We're not doing scoring or anything like that just yet, but we will do that in a later episode. So the first thing we're going to need to do is we're going to need to change the paddle slightly, because we need to get it so it registers every time. So if I go up here, this one seems to work, but if we go to the other one, which is exactly the same actor, it does just go straight through and doesn't register. Nice and easy way we're going to do it. We're going to open up our player paddle with control space into the content browser again. And in the components section over here, we're going to add a box collision similar to the wall. And we're going to make sure that it's set to overlap all dynamic. Then we need to make sure that this box covers the entire paddle and not much more. And we're also going to extend it slightly more, so if it hits the corner it counts as it bouncing, although we know it's actually hitting around there. So if we compile and save the cube, make sure it's got no collision, and everything else, capsule should have pawn. It can also have no collision as well, to be fair. Compile and save, and it falls through the floor, so we change that back to pawn. Then we play, bounces off the wall and bounces off the paddle, the wall, paddle. Excellent. We're also going to slightly change the ball's movement. So if we open up the Pong ball from the content browser and select the floating pawn movement, we can see these items here on the right hand side. The turning boost is the delay, or how quickly it turns and rotates, from the input vector that we use on tick. So this is all well and good, apart from what happens is as we flip, there still has some velocity moving one way, so it's actually decelerating rather than instantly changing. So highlight the floating pawn movement and change 8 to 1000 and compile and save. Hit play and you should see it bounces a lot quicker, which will definitely help when we start speeding things up. One thing we're going to do next is the debugging. So what we want to do is we want to make sure that it's bouncing in the right direction. So the one way of doing this is using a mirror by normal. So a normal is as a line goes out on something, if it hits a surface, it is the angle or the direction of that surface. So as I said on the last episode, a vector is a direction. The normal vector is the direction of the surface. So if you want to mirror by vector, this is the direction of the line, this is the direction of the normal, and it should bounce off. So under event tick, we need to, every frame, send out a line from the ball to where it's going to be. So what we want to do is we want to add a line trace by channel. And the start, we want the actor location. Not the set, get actor location. Now we want to end the channel, end the line trace, sorry, X number of units in front of the actor location in the direction it's moving. So we want to get the velocity. We want to times that by float. So right click on this bottom icon here and convert it to float. We'll set it to 10. And we want to add that direction to the actor location. What we can do, under draw debug type, you can choose one frame, duration and persistent. For this example, we're going to do persistent just for now, but for duration is very similar, apart from it's for a shorter duration. It does go after a while. If we load it up again now, you can see the line is drawn from the actor location all the way forwards. If 10 units isn't enough, you can add that a little bit more. You can see the line now extends beyond the actor. So now we want to make sure we can see exactly where this line is hitting a wall or a paddle, so we can calculate the direction it should be going afterwards. So in order to do this, we need to go into a wall or the paddle, because they're the only things that the ball is going to hit. And in the box collisions, we want to scroll down and change it to custom. And in the trace responses, if we go back to the ball, we can see line trace by channel, the visibility channel. So we want to block the visibility, file and save, and the same again for the paddle. Custom and visibility. So now if we compile and save and play, you should see a little box appear as that line hits the wall. It should also be shown for a paddle, but let's have a look why that's not. There we go. So what we can do from there is we can get the out hit from the channel, expand it, and then we have the impact normal. We can drag that and go mirror vector by normal and make sure that the impact normal is in the in normal field. You can hold Control and drag to move a connection, or you can click Alt and click to remove one. And we want the input vector to be the velocity. Right click and draw debug line. Give it a duration of 1 second, thickness of 5. Change the color to something other than blue. Other than red, sorry, which is the default line trace color. And we want the start to be the line trace impact point. And we want the end of the line to be impact point plus this direction. Convert that to a float times 50 or 100. Very similar to here, apart from we're using, instead of the actor location to start with, we are using the impact point. So now, that shouldn't be showing there, bear with me. Line start, the impact point. We need to add a branch with holding B and clicking. So it's saying if it does hit, so what was happening there is every tick, it wasn't hitting anything, and it was showing the velocity. So now it will only show a line if it's about to hit. Perfect. So now we've got a ball bouncing, it bounces off paddles, bounces off walls, we can see exactly the direction it's going to go, but at the moment there's no changing, there's no speed up, there's no nothing, it's not a really fun game. So we're going to change one or two things. So we want it, so if it bounces off a paddle, it's going to say paddle, it's going to change its velocity back to the other direction, and then we're also going to increase the speed. So we want to grab floating pole movement with control and drag, get set max speed, connect them up, and we want to do the same thing for get max speed. Times that by right click and promote to variable to make it nice and easy to change, speed multiplier, and we can set that compile so we can edit it to 1.05, drag that in, push play, and we should see that every time it hits a paddle it is getting slightly faster. But we won't know that because the change is so subtle we won't see it. So this is where another bit of debugging comes in. So under the tick we're going to add a movement, then we have some debug, but at the end of this debug we want to get how fast the ball's moving. So we want to print string, and this is going to be the speed of the ball. So we want get velocity of the actor, and this will give, just to show you, let's just rearrange it because it's only showing it's on hit at the moment. The direction of the ball. So if we change the duration to 0, then it only shows one at a time. And it should be the max speed. So we want the vector length that into there, and we can see the speed of the ball is at 300. Now it's on 347 because it hit the paddle 3 times. 364, 382, so it's getting faster and faster. And we can make it slightly more prominent. .732, and eventually it will get too fast to actually stay in the game. Perfect. Another thing we can do up here under the debugging on tick is we can get the current velocity, control and drag, and we can do a print string off of that, and we will be able to see exactly the direction that it's showing. Change the duration to 0, so you only get 1. Perfect. Compile and save. Control Shift and S to save everything in the project. So now, as we just saw, the ball leaves the area eventually because it's too quick, but we need something to close it and spawn it back in the game. So we're going to go to content browser, right click, new blueprint class, new actor, and we're going to call it goal zone. And the only thing we're going to have in this goal zone is add box collision, and it's going to be overlap all dynamic, because we don't need the line trace to be on here. And compile and save and close. Now if we go to our world, drag in the goal zone, press R to go to scale mode and drag it all the way out. And drag it up as well, so it shows a nice big area. Press W to change to movement, hold Alt and drag to the other side. I'm going to make sure they end up to the end of these walls, and I'm going to move this paddle in. Perfect. Under Pong ball, it's not going to hit wall, it's not going to hit paddle, so we want to drag off the other actor, cast to goal zone, cast there, and under goal zone, we can create a custom event, so which will just be goal. Ignore that, that's a comment for now, so we can come back to that. And then we want to destroy the actor. Leave it as self because it's this ball that's going to be destroyed. Under the goal, we're going to spawn a new ball before we destroy the old one. So right click anywhere, type custom event and type in goal. Drag off there, spawn actor from class Pong underscore ball. Drag off of spawn transform, type make transform. And the location we want to make sure is the same location what this is in, which is 7000. So we go back to the ball, 7000. And then from here we can drag off, call the goal event, and then it should destroy the actor. So at the moment this is going to spawn the ball in, but it's not going to move anywhere. So if we let the ball go past my paddle, you see it spawns, but the ball goes in the middle and it doesn't move. That is because if you go down to Pong ball and select the self, you have an auto-possess AI, which is one placed in world, but not placed in world or spawned. So placed in world or spawned, compile, save, and now when you load it up, the ball will bounce around, score a goal, and the next one will spawn. And the game just carries on. Next, we're going to make it so we can change the direction of the ball by the way that we control our paddle. So we don't want it to always bounce exactly perfectly, otherwise eventually you will be able to understand the path and you'll be able to guess where it goes. So what we're going to do here is we're going to make it so depending on the speed of your paddle, you're going to add velocity in that direction. So if you're moving up, you're going to add up velocity. If you're moving down, you're going to add down velocity. So in order to do that, we're going to need to firstly know our player paddle's velocity. So event tick, we're going to add a debug again. So get velocity. And we can split that because we only care about the X velocity, which is in the red arrow. So player paddle, so we just need the X, and we want to print string, and we're going to need to drag off the false, and we're also going to drag off of all of here. Change the duration to 0. And we'll change the color to something so we can tell the difference. So you can see it's on 0. As I move, it goes up to 600 minus 600, which is our max speed. So if we add 600 to the velocity, it's going to go directly upwards because it's between 1 and -1 at the moment. So what we're going to need to do is we're going to need to get the max speed, and we need to get the velocity as a percentage of the max speed. So if we divide the velocity by the max speed, and then if we print that, you should see it should range between 0 and or -1 and 1. So this value here is the one that we're going to need to add to the ball. So if we go down to our player paddle, we're going to need to grab information about this player paddle that is hitting the other actor. So we want to drag off of this cast node here, get velocity, and we want get max speed. Right click, split the struct pin, and on the on the X, we want to drag off, divide, get the max speed, and we want to add this. Use control to rearrange on the Y. On the X. I always get them confused. There we go. So Y mirrors, X adds. So now you can see that big paddle's not moving, so it doesn't change the velocity at all. But if I come down here, it's now at a completely different angle. Same as I can make it go back in its direction, or I can add it. And then once it goes past, it restarts. So let's remove the persistent line trace, and we'll change it to 1 frame so you can see just that one that is going. Just to make it a little bit neater on the eyes. And every time I hit the paddle, it speeds up. You can see the direction that it should bounce in. We still have a couple of bugs by the look of it, but this is great progress. Okay guys, thank you very much for watching episode 3. Hope that one wasn't too more complicated compared to the last one. I'll add some timestamps to it, and hopefully we'll start getting more and more complicated as it goes. Thanks for watching. Like and subscribe, of course, and obviously join my Discord server if you have any questions. Always happy to help. I'm generally here. And yeah, thank you very much, guys. See you next time.